All right, everyone. Hello and welcome to this Consciousness and Reality Colloquium series, the inaugural lecture. My name is Kunal Moole, and I'm a research scientist here at Caltech. This colloquium series seeks to inspire interdisciplinary investigations on topics such as the mind, cognition, consciousness, and the nature of reality. So I'm pleased to welcome today Dr. Christof Koch, who is giving the inaugural lecture. And I would request Caltech professor Pietro Perona to please introduce Christof.
So good morning, everyone. So I'm Pietro Perona, professor of electrical engineering and computation and neural systems at Caltech. And it's a great pleasure to have the opportunity of introducing Christof, who is a personal friend and was a dear colleague for many years with whom I've worked and enjoyed life also. So Christof is, as you know, a neuroscientist, and he's very well known for his studies and writings exploring the basis of consciousness. He started on the topic a long time ago, probably around 30 years. I remember him commuting to San Diego to see Christof, to see Francis Crick and brainstorm with him almost every month, I would say. So Christof was trained as a physicist in Germany, and he became a professor of biology and, in fact, the first faculty of the CNS program at Caltech in '86. And he was a faculty at Caltech for almost 30 years. In 2011, he joined the Allen Institute for Brain Science in Seattle as a chief scientist and also as a researcher. And he became the president of the institute in 2015. He's now the chief scientist of the Mindscope program at the Allen Institute, where he operates brain observatories to map and analyze and understand the mammalian brain. Christof also took on the task of being chief scientist of the Tiny Blue Dot Foundation, which focuses on understanding consciousness and its place in nature and how its understanding can benefit humanity. Christof has published extensively on many different topics in neuroscience, ranging from models, psychophysics, physiology, and has written several books, including an autobiography, which is very delightful. His approach to neuroscience integrates theoretical, computational, and experimental neuroscience with philosophy, the study of consciousness, and AI. So we're looking forward to hearing his story today.
Thank you.
Thank you.
I'd just like to remind everyone that everyone is encouraged to submit questions. And you can do that by clicking on the Q&A button at the bottom. So at the end of Christof's lecture, we'll be taking selected questions from the Q&A box. So please go ahead and submit your questions there. And let's welcome Christof Koch.
Thank you, Kunal. Thank you, Pietro, for that warm introduction. Kunal, I'm not going to look at the Q&A box because I find it very distracting, right? So if there are questions, they should come to you and you should ask them. Okay, I don't mind being interrupted, but I'm not going to read the box.
We'll take it at the end. Yes. Thank you.
So I'm going to talk about consciousness. I'll talk a little bit, but not too much about the brain, because this is not a neuroscience audience. And then I'll directly speak to the point of consciousness and reality. This is an experience. This is the conscious experience I had at the so-called near-death experience early on during the pandemic. It's an example of a conscious experience, a blazing point of pure white light of unbearable intensity without the conceivability of looking away. There's no way from. There's no space. Everything is contained in a point of pure energy. There are no other visuals, no color, no motion, no texture, no depth, neither sound nor silence, neither pain nor pleasure, no feeling of a body, no self, no ego, no memories, no desire, neither hope nor fear. No sensation of the experience being too brief or too long or wanting it to end. There's no time. There's only terror and ecstasy, that and the icy bright light. So it's a singular conscious experience. and which has little content. There's only this feeling of terror, ecstasy, and then this bright light. This is another conscious experience. This is sort of more of an everyday experience, you know, running here through the temperate rainforest. Though my calf muscles burn with fatigue, I will my body to continue to run along the forest trail. Looking ahead to avoid roots and rocks, I hear the caw-caw screech of crows in the canopy while thinking about a work-related dispute, but come to an abrupt stop to admire the breathtaking beauty of a beam of the rising sun slipping through the dark forest and striking a moss-covered tree, reminding me of a famous poem. So this is sort of what William James calls the stream of consciousness. It's filled with, you know, percepts. It's filled with, you can feel your body. You have this the feeling of wanting or pushing yourself. You have memories, you know, from the past, and you project yourself into the future. In this case, about a work-related dispute. Both are conscious experience. Both are ineffable, and both at this point don't really fit within the standard scientific framework of physics, chemistry, biology that has been so successful at explaining everything around us. But not this central fact of our life, the fact that we do have feelings. We do have experiences. We call them subjective, call them qualia. There are all sorts of different names: awareness, consciousness, experience, subjectivity. They're all different names, but they all refer to the same ineffable thing that we all have. When we don't have it, we are either in deep sleep, or we are anesthetized, or we are in coma, or we are in dead. And then we are no one to ourselves. All right. So you'll hear from a diversity of speakers that speak to consciousness. Many of them are influenced particularly by a particular tradition in Anglo-Saxon analytical philosophy, where there's sort of this widespread sleight of hand where consciousness is what consciousness is sort of replaced by what consciousness does. So rather than speaking to phenomenology, which is the central fact that has to be explained, people try to explain the function of consciousness, which is a perfectly legitimate question, but the function of consciousness does not address how the phenomenology comes about. Consciousness can be dissociated from computation, behavior, intelligence, planning, reasoning, social cognition, top-down attention, and working memory. It relates, of course, very often to those, but it can also be dissociated. In fact, you can get two ways dissociation, where you can get reasoning without consciousness. You can get social cognition without consciousness, and you can get consciousness without reasoning or social cognition. So it's really important to keep that in mind. The central problem is phenomenology. And as Erwin Schrödinger has remarked, phenomenology comes prior to physics. So before, even to talk about particles and accelerators and telescopes and measurement devices, well, I need to look at them, right? I need to interact with these devices. So it presupposes a conscious observer. All right, and then just a fun reminder here, every perception. So when we talk about perception, which is where most of the scientific experimentation has happened, whether that's a visual perception, auditory, tactile perception, etc., it is always a construction. In David Marr's word, every perception is a construction of a description. Right, so this argues against this sort of naive realist view. We see this here. Right, this is the so-called dress. Right, came out, went viral in 2015. About half of people will see this as black and blue. And the other half of people will see it as white and gold. Like for me, it's white and gold. There's just no dispute. It's not ambiguous. It's not like one of these percepts where you can flip from one to the other. A small set of people say they can flip from the white gold to the blue black interpretation, but most people see it either one or the other. And you can't say one is more right than the other. What it shows that that conscious perception is a construction, and it depends on all sorts of assumptions. In this case, we know it depends on the assumption your brain is making about the general lightness, the overall brightness in the image. Anyhow, this is important to remind us. What we perceive, isn't sort of some Ding an sich, isn't a reflection of a Ding an sich, but it's a construction of our brain shaped by the process of evolution. Right, so so typically when I talk about consciousness, sort of I speak about four aspects, because they have really have undergone tremendous change and progress over the last sort of 30 years. Pietro mentioned I first started to engage in this when I was at Caltech back in 1990s. Was my first paper 32 years ago on consciousness. So I'll talk a little bit about isolating the neural correlates of consciousness in the brain, tracking them. That's been the most progress. I won't talk about psychedelics. They are a fantastic tool to manipulate consciousness, of course. Then I'll talk about integrated theory of information, and I'll talk about biomarkers for consciousness. All right, so as I mentioned, I started this a long time ago with Francis Crick. Was commuting down from Caltech every month down to the Salk Institute, where Francis Crick at the time was working. And the idea is, independent of what philosophical attitude, no matter what ism, materialism, physicalism, dualism, or any of the shades of isms in between, we can all agree the brain is the organ of consciousness, not the heart, like most people in most cultures thought. It's the brain. And so we can look for the footprints of consciousness in the brain. So they're called the NCC, the neuronal correlates of consciousness, the minimal neuronal mechanisms that are jointly sufficient for any one conscious experience. So you can ask, when you see a German Shepherd, what mechanisms, let's say, what neurons? One interpretation says, well, it's all neurons that fire. Well, what is it about those neurons that fired in response to the German Shepherd that give rise to the conscious experience of a shepherd, while other neurons that are nearby that are also firing don't seem to be involved in the conscious experience? Where's the difference in NCC between seeing a dog or a cat, seeing it in color or without color, in stereo, hearing about a dog, dreaming about a dog, recalling in my dog, with the difference between, vision and audition, having strong positive feelings for a dog, all those different aspects. You can. Furthermore, it's a causal. It needs to really go deep. It needs to move away from mere correlation to causation. So the idea is that if you induce the NCC by a TMS device, or by a neurosurgeon's electrode, or by optogenetics, or whatever other fancy futuristic technology, you'll induce the experience. Conversely, if you inactivate the NCC, again, using various tools in people or in animals, you should eliminate the experience. And so this has been sort of the research program over the last 30 years of the field. It's very important. You need to distinguish the direct physical substrate of any one conscious experience from the background conditions. So these are the conditions that are necessary but not sufficient. So we know, for instance, your heart has to beat. Furthermore, your blood has to supply the oxygen to your brain through the arteries, the carotids and the other arteries. We know experimentally, and we know this from life, if you prevent oxygen from reaching the brain, you lose, quote, consciousness within 7 to 8 seconds. There's no power batteries, there's no backup in the brain, you lose consciousness. And so that's necessary, but it doesn't provide any specific content. We know this because there are people whose heart beats and whose brain is suffused with oxygen, but they are unconscious. Likewise, there are sort of background condition in the pons, in this structure called the midbrain reticular formation. It's a tube that extends, 2.5 inches here, and there are all sorts of nuclei there. They need to be intact. Typically, even small damage among these in the brainstem, in particular if it's bilateral, will typically lead to bad outcomes, including coma and death. So we know that these structures here are absolutely essential. They're necessary for consciousness, but they don't mediate any one specific content. Just like my laptop wouldn't work without having a power adapter there, right? But the power adapter, of course, doesn't compute, doesn't stream, doesn't play video, doesn't enable me to doesn't play video games. It's necessary for me to do all of those, but it's not specific. Same thing here with these enabling or background conditions. All right, so the evidence that I'm not going to discuss, I'm just going to discuss the type of evidence that you need to track the footprints of consciousness is primarily causal. I mean, the most important from an evidentiary point of view is causal evidence, where you manipulate things. So lesion studies, this is a natural occurring lesions. Typically, people suffer from a stroke, from ischemia, from traumatic brain injury, from bullets, from viruses, and all of that from the deficit that's left behind by these various calamities. Clinicians and scientists can infer which structures are necessary. So, for example, we know if you lose parts of your brain, in your visual cortex, you can, for example, become face blind, or you can unable to see color, or unable to see motion, although there's nothing wrong with your eyes per se. So that's been historically the most important source of evidence about which structures, particularly in cortex, are essential for particular classes of conscious experiences. Another type of causal manipulations are stimulation studies. So particularly in the context of neurosurgery, even today, as part of a normal clinical workup, a neurologist or epileptologist, before, let's say, they take out a part of the brain because it has tumor, or it gives rise to epileptic seizure, they will go in with an electrode and stimulate various parts of cortex. And so from those experiments, we know that some areas, particularly in the front, are largely silent. In other words, if you stimulate them electrically, the patient doesn't report anything by and large. If you stimulate motor cortex, the patient will twitch. If you stimulate auditory cortex, they might hear sounds. If you stimulate visual cortex, the patient will see visual percepts, so-called phosphenes. So this allows you sort of to directly intervene in the causal in the networks of the brain to see which ones have a direct relationship to some conscious experience. And people are doing this, have done this, and doing this systematically. Lastly, there's recording and neuroimaging studies that are very popular because they're relatively easy to do. You can put an electrode in a brain of an animal, you could do it in patients, or you can put people in magnetic scanner. So there's a lot of activity there. It's weaker in general because it's of course only correlation. And we've learned over the last 10 years, particularly from single cell experiments, that many states for instance, motivational states, hunger or learning or arousal, are represented in very large fraction of the brain. And so it's just not true, like we thought early on, that vision is just isolated to one part of the brain, and being highly or less highly motivated involves another part of the brain. All those signals can be picked up throughout the brain, and so that's a big confounder. So based on all these experiments, I'm not going to discuss it. Lots of papers I and others have written about it. In terms of the best tested aspects of consciousness, which is seeing, hearing, and touching, feeling, somatosensory, auditory, and visual cortex, as well as this interesting series of papers by neurosurgeons on wanting, willing. I have a desire, an urge. All of those conscious sensation involve a large part of the back part of cortex. So it's cortex, really. It's towards cortex, the unique hallmark of particular neocortex, the unique hallmark of mammals that we must look for the physical substrate of consciousness. And there it's primarily the posterior part, called the posterior hot zone. The front, paradoxically, although it's most enlarged in us relative to other, let's say, other great apes or monkeys, is involved, of course, in reporting experience, in pushing buttons, in memory, in planning, in intelligence, in social reasoning. But the evidence for its involvement in actual seeing or hearing or touching or similar conscious aspects is much, much less. And interestingly, neurosurgeons call much of this area here in front of the motor and premotor step, they call non-eloquent cortex, because you can stimulate it or you can remove much of it without any direct impact in the mental life. I'm not saying that there's no impact on the behavior. Of course, there is impact on behavior, but in terms of direct reported, people don't report that they see less or hear less. Rather interesting. Same thing, by the way, with the cerebellum. 80% of all your neurons in your brain are in the cerebellum. If you lose the cerebellum, you get various forms of ataxia, but your consciousness is not is not really impacted. None of these patients that lack part of the cerebellum due to lesion, or in fact, there are a few patients that are born without a cerebellum. They never had a cerebellum. They're clearly all clearly conscious. All right, I put this slide in because it's, many of you at Caltech are sort of come from a physics background. So I just recently organized a workshop at the Google Quantum Center at Santa Barbara, where we looked at all the evidence in favor or against sort of the supposition that's very popular, that consciousness involves collapse of relates to the collapse of the wave function. This goes all the way back to John von Neumann in the late 20s, early 30s, and of course has received a lot of interest. Particularly Sir Roger Penrose and Stu Hameroff have argued for this. The trouble with this, of course, anything that's not ruled out by physics is, is in principle possible, but in practice there are a few points here that are really important to remember. So brains operate at room temperature, 300 degrees Kelvin, roughly, in an aqueous environment. They're very strongly coupled to the rest of the body and to the environment, by evolution. Just as a comparison, if you look at, for example, a Sycamore, that's Google's quantum computer, right, 65 qubits quantum computer, operates at 10 to 20 milli Kelvin. So that's, more than 4 orders of magnitude less thermal fluctuation. So, of course, we know there's certain intramolecular phenomena, in particular photosynthesis, that depend on tunneling and coherence. This is reasonably well understood. Somewhat less understood, there's sort of primarily still at the testing stage. Quantum effects may also be important, macroscopic quantum effects maybe also be important for things like magnetoreception in cryptochromes. There's evidence, particularly for bird navigation, that this involves radical pair hypothesis, binding of volatile compounds to olfactory receptors. So there are a few cases of like that where it has been argued that the intramolecular phenomena that rely on, for example, the existence of quantum spins that are coherent. Right now, there's no evidence whatsoever for any phenomena like superposition and entanglement that are relevant for at the intermolecular scale, let alone at the intra and intraneuronal event scale. When we're talking about a neuron can easily be, a millimeter across or 10 millimeter across, including, or 20 or 30 if you include its axon. Typically switching of action potential involves opening and closing of tens of thousands of ionic channels that are all embedded across, many micrometers of neuronal membrane. So they're just, right now, all the evidence seems to suggest that statistical physics and, the quasi-static approximation of Maxwell's equation is all you need for relevant timescales at which consciousness operate, i.e. between, tens of milliseconds, several hundred milliseconds. So I'm always open for evidence, but so far the evidence really, there isn't really much evidence that there are macroscopic quantum effects in room temperature in the brain. All right, so there has been a lot of progress in the construction of a theory of consciousness by a good friend of mine, Giulio Tononi. He's a psychiatrist and neuroscientist at Madison. That really it starts with certain assumption about what exists, ontology, ultimately causal power, what exists, and proceeds from there to formulate an axiomatic approach to consciousness and what are properties of any conscious experience. There are 5 such properties that any conceivable conscious experience have that can't really be denied, that are indubitably true. From there, it moves from axioms into postulate, i.e. what is the character of a physical substrate. It could be transistor gates, could be neurons, could be anything what are the attributes of a physical substrate that it has to have in order to obey this particular axiom of phenomenology? And then it ends up with this view of reality where you're looking at a physical substrate like a brain. You unfold essentially its causal power in a particular way. It's a very precise calculus. There are Python programs that you can download where you can run this. It sort of unfolds the intrinsic causal power that in any way. So you take a mechanism in a particular state. It's very important, right? It looks at any particular physical system in a particular state where these neurons are on and those neurons are off, or those transistors are, the gates are on and those are off. It says, given this particular physical system, what are its causal powers? And in particular, it looks at the causal power of the system upon itself. You take a particular physical system at a particular scale. It asks, what are the causal power that the system has upon itself, its ability in its current state to influence its future and to be determined by the immediate past. And then it unfolds its causal power, and its central sort of dogma says, ultimately, what consciousness is sort of the unfolded intrinsic causal power of this system, such that every aspect of every one conscious experience maps one-to-one with nothing left over on either side onto that causal structure. So if you take the phenomenology of how space feels like or how my aftershave smells, every aspect of that has to map onto the intrinsic causal power of that particular system with nothing left over on either side. It makes some strong claims about what exists. It makes even stronger claims about two forms of existence: absolute existence, which is existence for itself, which is what consciousness is, versus sort of existence for others, which is what systems that are non-conscious have. They don't exist for themselves, they only exist for others. All right, so it starts with, the IIT starts with 5 phenomenological axioms that are indubitably true. They're consistent, independent, and complete, just like axioms in math. So it starts out with intrinsic existence. Every experience exists for itself, intrinsically, from within, independent of external observers. How could it be otherwise? Right now, if a conscious experience, you have a conscious experience that exists from within. That's what it means intrinsically. Every experience is structured. So, you have a left part of your field, a right and up and down. You have, smells, you have sounds, there are objects in your, in this case, a famous drawing from the physicist Ernst Mach, there's this body, there's bookshelf, there's window, etc. It's true for every experience. My near-death experience had three distinctions. Ecstasy, terror, and this bright light. Every experience is a specific way it is. It's differentiated. It is one out of many, right? So it is exactly what it is. Right now, I'm experiencing my laptop. All right. When I'm driving through the forest, I have a different experience, but it is always very specific. It's not a vague. Even if it feels vague, it is vague in a very particular way. It's not generic. There are no generic experiences. Every experience is specific. Experience is one, it's unified, it's holistic. You can't reduce it to independent components. So when I look at the world, I don't see a left field and a right field and they're stitched together. I only have one field of view. Of course, I can shift my eyes or I can shift my attention to the left and to the right, and then I perceive different things, but that's a different matter. For any one conscious experience, it is integrated. And lastly, it's definite. It is only one. There isn't a superposition of different conscious experience. So once again, I live here on a small island. And right now, it's very often very foggy and things are very indistinct. But even that indistinctness is definite. It's a particular type of indistinctness. And it's not more, it's not less. It's not that there are also other things that for example, my blood pressure. I'm not conscious of my blood pressure. That is not part of my experience. Although some baroreceptor in my brain are sensitive to that, but my conscious experience does not include the conscious experience of blood pressure. All right, so IAT infers the type of physical mechanisms because ultimately, it wants to refers to brains or maybe computers that are conscious, and which specific bits and pieces of them are really critical for conscious. So it goes from these axioms to postulates. So it starts out with that ultimately, as I said, it starts with an ontology. The principle of being that IAT assumes goes back all the way to Plato, Sophist. It's known as the Eleatic principle. So it essentially, or Alexander's dictum, it essentially says that for something to exist, it must take or make a difference. It must make a difference, it must take a difference, and it must make a difference to something else. Right. So for something to exist, if something cannot take a difference and doesn't make a difference to anything else, then it doesn't exist. Now, the way to compute how you make a difference, you ask how much causal power does the thing have, either upon itself, i.e. to influence its own future state, given its present state, or to be influenced, right? It's both make a difference and take a difference, to be influenced by its past to get to the current state. So you have some particular physical substrate. So it's an operational substrate. Let's say you do it at level of atoms or molecules or organelles or neurons or transistors. You pick a particular substrate where you have an intuition that this is the relevant substrate. In principle, the theory says you have to look at all substrate, and you have to look at all spatial scales and all temporal scales, and you have to pick the one that maximizes the intrinsic causal power. And that is expressed by a number called phi. It's a pure number. It could be 0 or bigger. And the theory says you have to pick the structure and the spatial temporal grain and the granularity that maximizes the amount of integrated information, that maximizes how irreducible the system is. Essentially, it uses it uses a transition probability matrix. You have a particular system like this one here on the left. You have some neurons with some logic and OR gate here, an AND gate and XOR gate. You have some external boundary conditions, and you want to, for example, compute how much causal power does this system have. It's a trivial toy example. The advantage is you can explicitly set up the TPM, the transition probability matrix. In this case, it's deterministic. It could also be stochastic. And you can ask, is this system, does it exist for itself? Does it have some ability to influence just these neurons here? Because in principle, you have to do that for every possible, for these neurons, for these neurons, for these neurons, just for this neuron, just for this pair. You have to look at over all possible subsystems or supersystems, and you pick the one that maximizes this. So this is the postulate that translates the first axiom of existence. Conscience exists from its own intrinsic perspective. You take this power approach, intrinsic causal power. You ask, how much intrinsic causal power does the system have upon itself? And then you can ask, well, for example, the composition axiom, you can ask, well, how many of subcomponents, if you have the full system, let's say those 3 neurons, how many of these subcomponents do they have intrinsic, if I just limited to that pair or this pair or that pair or this single neuron? The first order mechanism, second order mechanism, third order mechanism, principally you have to do it for all, for the entire power set. You can ask, how much intrinsic causal power does this system have within that structure? And for each of these axioms, you translate it into a postulate. Integrated says, well, finally, I'm looking for the system that has maximum causal power. And exclusion says only that system exists that has maximal intrinsic power. Only that system exists for itself. it's a pretty radical claim. So think about it. So you look at the brain and you look at all possible, I mean, in theory, in practice, you have to do all sorts of approximation, but in principle, you look at the brain and you ask, what is the substrate, the direct physical substrate for my current conscious experience, whatever it is. I'm looking at my laptop, and you ask that question. You ask the question of, well, the causal power of all various subsystems, you know, these neurons and those neurons, and you add the neuron over here, and you do that for all possible combination of all possible neurons, which is, of course, an astronomical large number. And then you say, well, the system ultimately that is a substrate is a system that maximizes the total amount of integrated information. Only that system exists for itself. Any subset of that system has smaller integrated information, is less irreducible, and therefore doesn't exist for itself. It still exists as an external mechanism. It still has external causal power, right? Because it can clearly influence other neurons, but doesn't exist for itself. And only what exists for itself is true existence, because that's existence for itself. That's consciousness, right? When you're conscious, even in a sleep, when you're dreaming, you exist for yourself. 5 minutes later, when you're still asleep, but now you're in a so-called delta wave, when you're not conscious anymore, if I wake you up and ask you what went through your mind, nothing went through your mind. That's what you say. You're unconscious. You don't exist for yourself. So that is not existence for itself. And so there are these two different notions of existence. Existence for itself, that is a system that has the maximal integrated information over a particular physical substrate at a particular spatial, temporal scale and level of granularity. And so here, essentially you take a mechanism here, it's a very simple mechanism of 5 different gates. You unfold all of its causal power, all of it's a vast number, it's super exponential. You look at all possible combination of you know, AB and BC and BD here. These capital and lowercase represent they are either on or off. You unfold all of its potential intrinsic causal power, and the claim is that this structure, it's a physical structure, because ultimately we're talking about we're talking about operational things. You take and make a difference. You, for instance, fixate this neuron and then you excite the neuron over there, right? You observe. Ultimately, it's a physical operational thing. So any conscious experience is identical to the maximal irreducible intrinsic cause effect structure. It's a maximum. Its quantity is characterized by phi. This is the integrated information. You can also think of it, to what extent is the system irreducible? The larger the phi, the more the system is irreducible to subcomponents. If phi is 0, the system doesn't exist, strictly speaking, and only its subcomponents will exist. Notice here, information in IIT is really the old, is sort of not Shannon information that's sent over a channel from A to B. It's sort of the Aristotelian notion, informare, to give form to. It's really much closer to Aristotelian thinking about form. So it has this really very powerful, IIT has this sort of this very explicit, I guess I should say, very explicit. It's rare to find that in science. Most sciences don't need that, but of course, when you're going to boundaries like, at the, superstrings, or at the larger scale, or when you come to consciousness, you really have to think hard about your ontology, what exists and how do you know it exists. So once again, the system makes this claim that true or absolute existence, only when you're conscious do you really exist in an absolute sense. That's true existence. In deep sleep or anesthesia, you don't exist for yourself, so you simply don't exist. You still exist as an external body, right? Someone else can observe you and you still sees your body, but you don't exist for yourself. So that's absolute existence. This absolute existence is existence for itself. Relative existence is existence for others. So the body still, of course, has extrinsic cause effect power. It still has mass, weight, stuff is still happening there. The heart is beating, but that's all for an external observer. So this really constitutes, and there's a really interesting philosophical debate about this, this really constitutes the great divide of being. On the one hand, you have entities that are conscious, like you and I, like dogs and cats and maybe worms and mice, and we don't know how widespread it is in the tree of life. Those is absolute existence, existent for itself. On the other side are things like black holes and rocks and my computer that exist for others but don't exist for themselves. Yeah, an intrinsic entity is the only entity worth being. I don't want to be, I don't want to be a zombie when I have no conscious feelings, right? And certainly when I'm dead, I don't exist for myself anymore, which is, of course, why we're bothered about the notion of death. All right. So there are all sorts of corollaries, predictions, explanation, extrapolation. I don't have time to talk about it. There are a few things one has to think here about, careful, and any theory of consciousness will have to address these. The vast majority don't at all. You have to explain not only the existence of consciousness, but why any conscious experience feels the way it does. So space, even when you're looking at a complete blank canvas, empty, nothing there, you can say, well, it's just empty, and that's it. But this emptiness, in fact, hides a vast sort of complex structure, bubbling force, if you want, because there's neighborhood relationships, there's distance relationship, there's inclusion, there's exclusion. All of that is contained within the notion of an empty canvas. I can convey to you exactly what I mean by empty canvas because you also have experience of space. So you know exactly, but that's a high-level label. If you really try to think about it carefully, it's a very, very, very complicated structure that has to be explained. How does space feel? Whether it's seen space or heard space or felt space, all similar. Time flows famously, right? Flows, and it only flows in one direction, of course, right? And perceptually, well, that needs to be explained. Why objects feel very different, why colors feel, and why, pain feels a particular way it does, right? All of that has to be explained. So not just the existence of consciousness, but why do different things feel so differently? You have to explain a lot of facts. So, for instance, as I briefly mentioned, the cerebellum. In fact, here's a picture, an MRI scan of a woman who turned out, they discovered when she was 24, she was born without a cerebellum. So when us there's a cerebellum in her, it's just filled with cerebral spinal fluid, okay? Why? And we know this also from other people who lost parts of cerebellum due to surgery, falling tumors. People don't complain about loss of consciousness. Why not? There are these beautiful neurons here, cerebellar neurons, among the most beautiful and the most complex neurons in the brain anywhere. It has maps, it has representation, but it doesn't seem to be involved in consciousness. So IIT is something to say to that. IIT also came up with this new, I'll just be again very brief here, I'm almost done, biomarkers for consciousness. This is really important because there are tens of thousands of people, patients, who following either acute patients or chronic patients, they can be in the state for many years, following a stroke or a heart attack, following with ischemia or traumatic brain injury, car accident, blunt object trauma, etc., unconscious. They are clearly alive, although very often, usually, in fact, they are on life support. Sometimes they may open their eyes for several hours and they close them again, or they might groan or move about. But we have no evidence at the bedside. The classical way, it's how it's still done today in 2022. You ask patients, Mrs. So-and-so, can you hear me? Can you move your eyes? Can you move your finger? Can you move your neck or anything? There's a significant fraction of people that are unable to do this. And so they're called either, when they can do it occasionally, they are called minimal conscious state. When they can't do it at all, they're called vegetative state. If this lasts more than half a year or a year, it's called PVS, persistent vegetative state. In some cases, like Terry Scheiber, she was in this state for more than 14 years. The other thing is very often in acute care, after 7 or 10 days, if the patient is in this state, very often in consultation with the family, critical care is discontinued and they withdraw life-supporting care, in particular ventilator support, and the patient dies in the absence of precise diagnostic and prognostic indicator of the presence of consciousness. So right now, there's simply no tool that tells me this patient right now is conscious. So out of IIT came this tool. It was first published almost 20 years ago. Essentially, it's a high-density EEG device, and then you apply a magnetic pulse. So it's like you essentially ring the cortical bell. It's like, you hit a bell with a hammer, and you're listening for the resonances. In this case, you hit it with a magnetic pulse that induces, via Maxwell's law, induces current in the cortex, and you're listening to its echoes, and you essentially compress it. And it turned out there's a magic number, 0.31. If the complexity of this resultant brainwave is below a threshold, then in every case where it's been tried now in several hundreds of volunteers and the patient or the subject is either unconscious, either because they're in deep sleep, or because they're anesthetized or doing different types of anesthetics, or they're in coma, or they're if it's above this number, they're awake, normal, or they're in a REM sleep, or they're on a ketamine where they don't respond, but they're clearly conscious because they're in a dissociative state. And so this is now being tested in clinical care. All right, a few more implications of integrated information theory. So integrated information theory argues that consciousness can be graded. So it has many aspects of panpsychism. So for example, if you just look at the mathematical calculus here, you have this particular neural network where you have, where you have this quintuplet of 3 neurons, and if I just look at these 3 neurons is 0.19, but if I look at the entire network, it's 10. So the theory says this entire thing is conscious. Now you're noising it. So you're adding here more probabilistic and connectivity. This remains the same. The overall intrinsic causal power that the network has becomes weaker because there's more random events here, and the phi goes down. But this is still the maximum. You add further. A noise, and then suddenly what happens? Now the maximum isn't the whole anymore, because the whole only has 0.03 integrated information. It's rather these individual triplets, the 5 of them that are conscious. So here consciousness sort of systematically goes down from 10 to 0.19. So the intuition here, which is shared by this very ancient view of looking at consciousness is probably much more widespread than we think. It's certainly my belief, if you look at possibly throughout the entire tree of life, that even very simple creatures, it may feel like something, right? This is clearly not going to feel a lot. This thing isn't going to think about its weekend. It doesn't have a lot of distinction. But there could be as simple as distinction as being versus non-being, on versus not on. IIT answers sort of this. Again, it's a very old question going back to the Greek, the mereology, the relationship between the part and the whole. So, which systems are conscious? A single bacteria, the microbiome, ants or ants colony, bees or the beehive. For us, it's really the whole cortex. I argued briefly, it's a posterior hot zone. So if that's conscious, then the individual neurons cannot be conscious, because it's always the maximum over the substrate. So you can have the 2 individual hemispheres are conscious, like if you cut in the corpus callosum, you cut the 200 million fibers connecting the left and the right, but then you have two separate minds. It is possible, and the theory tells a way how to do that. You can take 2 brains, you can do sort of the inverse of a split brain. You can start connecting brains directly to each other using some futuristic, Neuralink-like technology. And at some point, there will come an abrupt, sort of almost like a phase transition, where you add 1 more wire, and suddenly the 2 brains will be conscious as a single entity, but the individuals will disappear, will not be anymore. You can make this claim that it's very strong anti-functionalist claim. You can have 2 systems that have identical input-output table. So you can have this system here that has sort of 6 neurons that are heavily networked, and you can have the input mapping onto certain outputs. You can unfold the system if you want into purely feed-forward structure, where you can show that for a limited amount of time, this system on the right, the feed-forward, performs exactly the same function as this system on the left. Of course, if you look under the hood, they're very different. And IIT says the substrate really matters. It's not about input-output transitions. It's not about input-output transformation. It's really about the physical substrate. Since this physical substrate is very different, their phi is going to be very different, although they perform the same function. So it's really a very anti-functionalist argument here. All right, let me come towards the end. So in a strict sense, IIT says experience has no function, just as electric charge, in physics doesn't have a function. It's a property of certain physical system. IIT says, yes, certain systems that have integrated information, that have finite integrated information, they will have power upon themselves. It's just a feature of the universe. Now, of course, you can do this. We've done this a lot of simulation with artificial life. You can show that under evolutionary pressure, it leads to systems that have high integrated information, but that's indirect, because what, of course, evolution selects for is behavior, right? Evolution doesn't select for internal states. Ultimately, evolution will only select on explicit behavior. So in this view, consciousness would be more like a span rail, evolutionary speaking. As I said, integrated information theory is not a theory about cognition. It's not a theory of computation. It's not a theory about input-output transformation. It is really a theory about what fundamental exists, which is causal power, particularly intrinsic causal power upon itself. And my last slide here, we could spend an entire hour on this, but it really makes this strong point, this dissociation between function and being. Consciousness ultimately is a state of being. Intelligence, no matter how you define it, ultimately it's a function. It's adaptive, complex behavior in environments that have, actors operating at multiple, time scale, etc. But the theory says, well, so you look at evolution. So evolution brought forth a series of creatures, from the medusa to bees to mice to Bernese mountain dogs to Madame Curie, that clearly are intelligent by human measures and clearly are conscious. And probably the intelligence of these creatures goes up on some scale, and their consciousness only goes up. And that's what we expect throughout evolution. That's what we've had throughout history. But now we're in a position to engineer systems that can be double dissociated. We can, in principle, engineer, cerebral organoids that may have no behavior because we don't connect them to input sensors, or we may not connect them to output sensors, but have cortical structure. So in principle, these systems could be conscious. Right? There's now a vigorous debate in medical ethics. If you get these systems, they have few million neurons, they begin to show EEG activity. To what extent are they conscious? Well, the theory says in principle they could be conscious. Conversely, you can engineer systems that are, very, intelligent by some measure, where you can certainly have a conversation with, but they, given the intrinsic causal power at the level of the substrate, where sort of the rubber hits the road, actually at the level of the transistor, because of their connectivity is radically different from connectivity of brains, you can show their integrated information is minuscule and doesn't depend at all on their program. It really only depends on the physical substrate and the way it's wired. So you get this double dissociation. You can get high levels of consciousness in an engineered system without intelligence, and you can get high levels of intelligence without consciousness. And with that, it's a view from our island I took a couple of a year ago. And with that, I thank you for your attention.
Excellent. Thank you very much for that thought-provoking talk, Christof. And we have many questions in the Q&A box, although I would like to ask you one very quick question, which is on the lines of the theme of this colloquium series. Is your talk was about the physical substrate of consciousness. Do you think there is a non-physical substrate of consciousness? And if so, what is the meaning of reality itself? And what kinds of realities would consciousness have access to?
So this theory only deals with things that have causal power. And so unless, something has to have causal power on itself or on others. If it doesn't have causal power, then it doesn't exist per IIT. I had this discussion with His Holiness the Dalai Lama, and at some point we came to incarnation. And I thought, well, look, Your Holiness, I can give you a koan of 4 words: no brain, never mind, right? So once I die, unless there's some physical substrate, it could be very esoteric, it could be, space-time waves or whatever, is spatial. But unless there's a physical substrate, there isn't anything there. So without a physical substrate, you're not going to get this causal unfolding, because ultimately it relies on causal power.
Thank you. We will go to the questions. Some very interesting ones related to, again, the things that we were talking about in terms of the space and relationship with consciousness. Is one of the questions here is, do we actually have any understanding as to whether the currently known basis set of electrical and chemical activity is sufficient to span the space necessary to explain brain computations, let alone consciousness?
Let's put it that way. We have no evidence to suggest it's otherwise. What we don't know, we can't exclude, right? Those are Donald Rumsfeld's unknown unknowns, right? So, but right now we are going on the assumption that the brain, we have in principle all the components. What limits us is the vast complexity of the brain. Look, we now realize over the last 10 years, partly through the effort of the Institute, that the brain consists of 5,000 different cell types. So think about having a computer where you not just have AND gates and NOT gates and NOR gates, but where you have 5,000 different components, and then you have a few million of each of them. This is staggering complexity, right? That ultimately, I think, is what gives rise to consciousness. We have no knowledge of any other laws that might be out there that might help us, but we have no reason to suppose either that they exist or that they are necessary to explain anything physical about the brain.
Thank you. Next question is by Rachel Reyes, who asks, neurons as a constituent substrate to consciousness is well accepted, but has there been any studies regarding the genetic correlates of consciousness?
I don't quite know what you mean by that. I mean, we know that, you need at least in neurotypical humans, you need cortex. So we can then ask, and of course, people addressing the question, what is the genetic basis of cortex? So that we do know, but I'm not sure what the genetic basis of consciousness would be. To me, it would be to give rise to the necessary physical substrate that ultimately is the substrate of consciousness. Yeah, so I can't really answer that question very precisely.
All right. The next one is by Peter Schroeder, who asks, what about plants? Recent research by Gagliano and others would seem to justify attributing memory and learning to plants.
Hi, Peter. Yeah, so I've looked at the evidence. So I would say the evidence is promissory. It's interesting, but somewhat iffy. But at least if I look at, so again, IIT says, let's look at the substrate. So you have to look at actually the plants, and you have to look at the way they're organized. They don't have, for example, anything like axons, where one neuron can reach straight across the brain to make a very specific connection with the neuron on the other side. Plants and also trees, because there's this interesting question, does it feel like something to be a tree, are sort of much more local. So in principle, it's a question that will have an answer. It may well be that a plant feels a little bit like something. I would say the current evidence for high-level learning is still very out there, but it's interesting. The other question is these networks, right? These networks of roots in forest. To what extent is complex information processing ongoing there, and could that be a substrate? Possible.
Excellent. Next one is by David Anderson. If the essence of consciousness is feeling, and if all feeling in living organisms ultimately depends on interoceptive or exteroceptive sensory inputs, how can a system without sensory neurons, for example, brain organoids, which are purely seen as derived, be conscious?
Good. Hi, David. Good. Well, so it's a good question. What would a cerebral organoid feel like? It would probably be, so let's say it has topographic connection. Let's say, for the sake of argument, you know, I managed to build a primary visual cortex, you know, using the latest tissue technology, right? And it has local connectivity. The way it feels like, I think, would be it would have some sort of inkling of space. It wouldn't have any sense of self, of past, of future, but it would have a simple experience just of extended space. And maybe if there's local excitation, you know, maybe it has some sort of, it sees, you know, sort of something. But it doesn't interpret it, of course, because, you know, in order to say there's something, an object out there, you know, I need to have interacted with the world. So it would feel something, according at least IIT, but it wouldn't be probably anything you could recognize, unless, you know, maybe in a near-death experience, when people have, you know, these strange description of what, quote, they see, unquote.
All right, we have one last question by Joe Stover, who I know is a professor of mathematics. He asks, do you think that consciousness could possibly be due to a specific physical field, for example, analogous to electromagnetism, that is not purely computational or integrated information, but requiring that in the specific physical field? So a complicated computer composed of flowing water in pipes, or say a quark field, etc., would not ever generate consciousness?
Yeah, I mean, I don't know. I'm skeptic. I know there's a number of these field theories around. I mean, the most popular candidate, of course, is the local field, you know, the electrical field. You can put an electrode in the brain and measure it. It doesn't have really the precise properties required to represent my conscious experience, the high level of very detailed granularity that I have access when I look out at the world. I mean, you know, I don't know about any other fields in the brain. The only ones I can see, you know, the only ones that can physically interact are, you know, in this sort of frequency domain, you know, using the electromagnetic waves. So, and I don't think that's involved in the brain, although of course it's a side effect of highly excitable neural tissue, but it doesn't look like that supports our conscious experience.
All right, with this, let's thank Christof Koch again. I would like to say that Christof will be at Caltech in February next year as a Wiersma visiting professor. So let's look forward to interacting in person with Christof. But the plan currently is that sometime next week, we will be having a interaction session and discussion session with Christof virtually, and especially for graduate students and postdocs. So, so stay tuned for that. And in closing, I would like to say that these colloquia, which are part of the Consciousness and Reality series, will be held once a month. The next colloquium will be delivered by Sean Carroll, who is a Homewood professor of natural philosophy at the Johns Hopkins University. And some of us may know that he used to be around at Caltech. And this next colloquium will be on the 7th of December. So let's thank Christof again, and to all participants, thank you for being here, and to everyone who has worked behind the scenes to make this event happen. Thanks so much, and you have a good rest of your week. Take care.